So our first speaker is Nick Giudice. Nick received his PhD in the Cognitive and Brain Sciences program in the Department of Psychology from the University of Minnesota in 2004 and worked as a postdoctoral research fellow in the Psychology and Brain Sciences program in the Psychology Department at the University of California, Santa Barbara from 2005 to 2008. He joined the University of Maine in the fall of 2008 and is currently a professor of spatial informatics in the School of Computing and Information Science with a joint appointment in the Department of Psychology. Nick is the founding director of the Virtual Environments and Multimodal Interaction Laboratory, so some of you might know that as VEMI. The VEMI houses Maine's only research facility combining a fully immersive virtual reality installation with augmented reality technologies in an integrated research and development environment. Research in his lab uses a combination of behavioral experiments and usability studies to investigate human spatial cognition with and without vision to determine the optimal information requirements for the design of multimodal interfaces, and is a test bed for evaluation and usability research for navigational and information access technologies, for blind and low vision users, older adults experiencing vision loss, and sighted individuals who are situationally blind. And the example is texting while walking, just so you know that situationally blindness. Which is, I think we should throw that at people personally, like, hey, stop. Anyway, Nick is himself congenitally blind and has a long history of both designing and using assistive technology for navigation. He has authored or co-authored over 170 scientific publications relating to the study and design of multimodal access technology for blind and visually impaired people, collaborated on over $10 million in research grants in this field from the National Institutes of Health, National Science Foundation, and NIDILRR, I don't know what that is, I'm sorry. And has advised over 50 students. Nick has also been on the program committee of dozens of scientific conferences and workshops, is on the scientific advisory board of 2 information access companies, and is a current board member on 2 blindness-related organizations, and is the co-founder of 2 startup companies dealing with information access technologies. So he sleeps a lot. That's what you get out of that. And I've asked all of our speakers to kind of give me some pop culture-ish science thing they like. I told them I'm trying to humanize them for you. And Nick said he likes She Blinded Me by Science. So welcome, Nick Giudice. I'm right here. So we can go over more?
So if I knew you were going to read that, I wouldn't have put it. I didn't even know I'd done all that. Bring it down. Dog was saying, so I'm not even talking about most of that. I'm really giving you. Oh, well, that's. I don't want my time to start. I'm just saying. So most of what I'm talking about is a position and kind of an idea more than about my work. So thanks, Kate. Good evening, everyone. As somebody who works in the tech field and someone that thinks a lot about technology design, I've become increasingly concerned about a problem of current technology development. And that really is how current user interfaces that we use are almost exclusively based on vision and visual information. And so in other words, they are blind to the reality of how we actually experience and interact with the world around us based on this kind of rich multimodal information that we get from all our senses, vision being just one of them. And so the problem with current technology design is that it ignores what we can learn from the most powerful computer in the world, that is the brain. Next. The brain is better than any computer in simultaneously perceiving, processing, representing, and acting on information from multiple senses. Even tiny mouse brains are better than any computer that we have. So why is most technology still limited to typing and tapping for inputs and visual displays for output? This is kind of silly. It's not how we actually experience the world around us. Our natural interactions involve seeing, hearing, feeling, tasting, smelling. We communicate by talking, pointing, gesturing. So what's the deal with computer technology? Next. There's a bunch of explanations. Partly it's because visual interfaces give us the most bang for the buck. It's hard to develop interfaces and using different channels of of sensory information. It requires more knowledge. It gives more room for people to screw up. Partly it's an inertia problem based on what has always been done and what is good enough. I'm arguing today that good enough doesn't cut it anymore. We need to adopt new bio-inspired technology design that's based on how the brain uses multisensory information for both input and output. Next. This is starting to happen. So we have smartphones. Smartphones are really great at using sight and sound and touch and gesture. We have non-visual interfaces like Alexa that are changing the landscape. We have new gestural interfaces. But this needs to become more the norm than the exception. Next. My belief in the importance of tech, in the multimodal aspect of tech, is based on a hypothesis that I want to quickly talk about. I think it's important. So I argue that the majority of what most people call visual information isn't really visual. It's actually spatial information. And I don't mean space like outer space. I mean like space like what's around us in the environment. And the take-home message here is that while vision is a great conduit of spatial information, we have this big pipe from our eye to the back of our head. It doesn't have a monopoly on space. Actually, all of our senses are really good at conveying spatial information. And this theory has lots of scientific evidence. I worked on this. I'm not showing you any data tonight. But the results are clear that they suggest how we can use sensory information and sensory channels as part of technology development, and that they can support the same type of behavior, no matter what one you use. And this information is important because it shows that adopting multimodal interface design will benefit the most people, whether they're people with disabilities, older people, or really anybody, because it's how the brain actually works. Next. Let me just clarify this theory with a brief example. So imagine that you're standing at this table. There's items on it: bottle, fork, plate. And I'm going to bet that you are equally good, equally fast, equally as accurate as reaching and grabbing for the bottle when you're using vision to guide your actions, as if you closed your eyes and tried grabbing them by touch alone. And the reason is that the representation in your brain that you've built up is based on spatial information of this arrangement, independent of each individual modality. Next. My take-home here, this is so fast. My take-home, we need more bio-inspired technology design based on the brain's playbook for natural interactions. Okay? We need to move beyond the vision-only bottleneck of technology design to support multi-sensory information input and output channels. And we need a heck of a lot more, this is a family thing, crosstalk between scientists, engineers, and technology developers in developing the best technology. Next. Thanks, everyone.
It is really hard. You can't go yet. Oh, we've got questions. Oh. So we have questions. If anybody has questions, we have 5 minutes of questions. You can, no, you got to go. Please go right to the microphone. Sorry. I discovered it's too easy for me to trip. So please go ahead.
Do you envision, as I do, a day when there is an implant in the brain that makes our brain much better at things that it doesn't do very well now, and makes us smell like dogs and that?
Ooh, I don't know about the smell. So I ask students this every year, and every year more students say they'd be willing to do this. Yes, the answer is yes. Whether that's good or not, in terms of when we start getting into neuroviruses and hacking and what have you. But yes, we are going to be able to do BCI, brain-computer interfaces is the next technology, for sure.
So it sounds like basically what you're looking to do and asking us to do is accept technology as another human being. So to accept something that we can't see its brain and interact with it. How do you get past that?
Well, in some ways, so I'm very interested in autonomous vehicles right now, and the biggest part that I'm interested in is not what's being looked at, and we're calling it human-vehicle collaboration, and it's how you can trust these vehicles. We learn to interact with the technology, but the technology has to also learn from us. We have to be able to trust, especially in something like an autonomous vehicle where our life is in its hands. We have to figure out ways to communicate and humanize. You know, we're human. Look at Alexa. You call Alexa, Alexa, it calls me, you know, when I swear at it or whatever, it calls me by my name and chastises me. We're doing this humanization, and that's going to continue and make a difference in how we interact with technology.
So you mentioned that in real life we use all of our senses to create a spatial model of our environment. If you sort of had to rank them, I assume sight would come first, but maybe not. How do we build the model? I mean, is it touch? Is it hearing,
Vision's by far
smell?
the most. Yeah, vision's by far the most. We have the most neural hardware dedicated to it. Oh, there's the mic. Hi. Oh yeah, I can hold it now. And it has the biggest field of view, most resolution, but then touch. So if you touch or you feel the edge of the chair that you're on, the stimulus is the same. And so there's the most similarities with vision in terms of the spatial properties. Then hearing and spatial hearing. And then smell and chemical senses are harder because they're very distributed. But this is very fast, Kate.
This is really fast.
No data and fast questions.
And another question.
Quick.
Go ahead.
Could you tell us one or two things that I think you mentioned that there's a lab at Maine. Could you just tell us one or two things that have come out of that lab?
Yeah, so the VEMI lab is the lab that I direct and a lot of us are in. One thing is a tactile screen reader. So when you use Siri or something that reads what's on the screen, it reads speech. And you can use text-to-speech to read all types of text, but there's nothing that allows you to access graphics. We've developed an interface that allows you to feel and hear graphical information, which is good for eyes-free applications like in a car or someone that can't see in a STEM disciplines. We've also developed some indoor navigation systems and different technologies for specifying how to describe something instead of saying, oh, it's over there, which tells you nothing.
How is the multisensory approach applicable to artificial intelligence?
We're going to need more than 5 minutes.
You only have a minute.
Oh, there's a lot of application, but at the end of the day, the hardest part with AI is that it's mostly modeling from a bottom up. So it's saying, here's the incoming data that we can quantify. It's not taking the top down processing of how we're integrating this information into models and how our priors and our experiences are changing that. That's a challenge, but yeah, we could argue for a long time, I'm sure.
And I think we're going to let Nick off the hook here.
One more, I want the bell.